Hello, very good morning to all of you. Am I audible? Hello, am I audible? Hello, am I audible? Hello, can you hear me? Hello, am I audible? Hello, ಕೇಳಿಸ್ತಾ ಇದೆಯಾ ವಾಯ್ಸ್? ಹಲೋ, ಸಂಜನಾ ಟಿ.ಎಸ್. ಸಂಜನಾ ಟಿ.ಎಸ್. ಚೈತ್ರ ಎ.ಬಿ. Chaitra,
Yes, sir.
am I audible? Shall
Yes,
I
sir.
continue the class?
Yes,
Okay.
sir.
So far we have discussed the definition of hydrology and hydrology cycle, that is the descriptive hydrology cycle, Barton's qualitative hydrologic cycle, and the engineering application of hydrologic cycle. And we have also discussed the global water potential and also the water potential of our country. And we have discussed the different forms of precipitation and also the different types of precipitation. The different forms are the drizzle, rain, snow, hail, sleet, snowflakes, etc. And the different types of precipitation are the thermal convection or convectional precipitation. The second one is orographic precipitation. And the third one is cyclonic precipitation. And the fourth one is frontal precipitation. And we have also discussed the scope of hydrology in the last class. Now, let us discuss about the applications of engineering hydrology. So hydrology is used to find the maximum probable flood at proposed site, that is at a particular reservoir place or dam place, what will be the maximum probable flood that may occur and what is the frequency of occurring these flash floods, and also the variation of water production from catchment can be calculated and described by hydrology. So that the yield from the catchment can also be calculated quantitatively by using the knowledge of hydrology. So engineering hydrology enables us to find out the relationship between a catchment, surface water and groundwater resources. So since in a catchment area, the surface water and groundwater are treated as integrated. So both are treated as integrated. So in order to estimate the maximum yield from the catchment area, so we consider the surface water as well as the groundwater potential in that particular catchment area. And the hydrology also helps us to know the required reservoir capacity. So what will be the storage capacity of the reservoir, which basically depends on the yield from the catchment. That is how much volume of water or how much quantity of water that joins the stream. So that will decide the capacity of the reservoir. So if you build a very big reservoir having a small capacity, then the reservoir becomes uneconomical because for construction of reservoirs, you require a lot of money and various human resources and material resources are involved. So if the capacity of the reservoir is more than actual quantity of water that is available that can be stored, so hence the reservoir project becomes uneconomical. So the hydrology also tells us what hydrological hardware, that is rain gauges. So we need some of the equipments to measure the rainfall in a particular area. So these equipments are called as the rain gauges. And also in case of streams, so you can measure the flow in the particular stream by stream gauging methods. So we have equipments like current meter and other equipments by which we can also calculate the velocity of the stream and also the quantity of water or the discharge through the stream, so that it can be a useful information for the calculating the capacity of the reservoir. So hydrology is also used in prediction of flood over a spillway at high culvert or in urban storm drainage. So normally what happens in cities like Bangalore and all, whenever a heavy rainfall takes place, so many areas are got flooded with the surface water. So that is, so the concept of the knowledge of hydrology will be used in prediction of flood over a spillway. That means the excess water in the reservoir has to be disposed of through the spillway openings or the spillway gates. And also in case of highway culverts, we have to design the quantity of flood water that can be easily taken away in case of highway culverts, so that the whole area does not get inundated. So also in urban areas, we need to drain off the surface runoff. So that is a major problem in major cities. So due to the lack of infrastructure facilities or strong drainage, the whole area gets inundated. So the knowledge of hydrology is also used to assess the reservoir capacity required to assure adequate water for irrigation and municipal water supply during droughts. So basically the reservoir is a multi-purpose reservoir. So the purpose of constructing a reservoir is to store the water during the rainy season, and the same water can be used in the non-rainy season, or whenever there is a severe drought in a particular area, whatever the water that is stored in the reservoir, it can be used. So hydrology is an indispensable tool in planning and building hydrologic structure. So basically, in order to plan and design and operate any hydrologic structure, the knowledge of hydrology is very important, because the hydrological data is very important in order to estimate the capacity of the reservoir. So hydrology is also used for city water supply design, which is based on catchment area, amount of rainfall that occurs in that particular catchment area, and any dry period. Sometimes what happens in a particular year, there might be no rainfall, there might be no rainfall. So such periods are called as the dry period. And also the storage capacity, the runoff, evaporation and transpiration. So it also helps to know the amount of water that is lost to the atmosphere through the process of evaporation and also the process of transpiration. So dams construction, reservoir capacity, and also you can decide the spillway capacity, the size of the water supply pipeline, and water supply scheme. So basically the knowledge of hydrology will be very helpful in many areas, that is in the design and planning and operation of hydraulic structures. Now, so we have discussed what are the practical applications of hydrology in the last class. Now, these things we have already discussed. Now, so for hydrological analysis of a particular area or a particular catchment, so we need so many data we require to analyze a particular catchment area, or in order to calculate the yield from a particular catchment area. So the data which are required for the hydrological analysis, the first one is the climatological data of that particular area. So whether it may be a summer season, or it may be winter season, or it may be a rainy season, then we require the hydrometeorological data. Hydrometeorological data constitutes the temperature of that particular area, that is the mean and that is the minimum and maximum temperature in that particular area, and what is the wind velocity in that particular area, and how much percentage of humidity in the atmosphere is also required for the hydrological analysis. And also the third data we require is rainfall or precipitation data. What is the amount of rainfall that has taken place in that particular area? And also we need to have the stream flow records. What would be the possible runoff which joins the stream from the catchment area. So that is called as the stream flow records. And also we require the crop and their season. So on the downstream side of the reservoir, the water is used for irrigation, and we need to assess the type of crop in that particular area and the area in how many hectares the crop has been grown and in which season the crop has been grown. That is, any crop takes a minimum 4 months from its sowing to harvesting. So we need the crop to be grown because different crop require different water requirement. So that is why this data is very helpful. That is crop and the growing season and also soil of that particular area. So whether the soil is permeable or impermeable, whether it is sandy or silty. So that information is also required for hydrologic analysis. And also we require the evaporation and evapotranspiration data. The evaporation from the free water surfaces like ponds, lakes and reservoirs, and also the evapotranspiration, that is the water lost to the atmosphere through plant leaves and also from the crop irrigated land or forest vegetation. So all put together, it is called as evapotranspiration. And also the land use and land cover. So how the area under the downstream side of the reservoir. So what is the process or method of using the water or the method of irrigation? So that is the land use and land cover. And the groundwater potential of that particular area is also required for hydrological analysis. Wherever there is a scope to extract the groundwater, and the same can be used for minor irrigation purpose. So the groundwater statistics of that particular area is also important. And geomorphological data. So the geomorphological data is nothing but the shape of the basin, the size of the basin, the slope and elevation of that particular basin with respect to mean sea level. So normally in any hydrological analysis, we require number of data, and these data are spatial and temporal. So hence, in hydrological analysis, we cannot predict 100% accuracy, because all these data have some variables. Too many variables are involved in this hydrological data. Hence, we can reasonably predict the amount of rainfall that may occur in a particular area. So these are some of the hydrological data that are required in hydrological analysis. So now we have already discussed the distribution of earth water. What is the global water resources? Already we have discussed in the offline classes. So now we have an equation for any particular catchment area, So this is the equation. So this equation is called as water budget equation. So you can see here, it is also called as water balance equation, or it's also called as water budget equation. So the water balance equation or water budget equation for a basin states that all the water that enters in a system, so the entire catchment area is considered as a system. So all the water that enters in a system, that is in the form of rainfall or precipitation, in a specified period of time. So here, everything, all the hydrological data is temporal, that is, it is time-based. So in a specified period of time must be consumed, stored, or go out of the surface or subsurface flow. So now the definition is nothing but, so the inflow into the catchment area is nothing but your rainfall. The inflow into the catchment area is nothing but your rainfall. So this is nothing but the input into the catchment area. The input should be equal to the output. Output is nothing but the outflow from the catchment area, which is nothing but the overland flow or the surface runoff, plus or minus the change in storage. So whenever the rainfall takes place in a particular catchment area, some portion of the rainfall will not reach the ground surface. It will be returned back to the atmosphere without reaching the ground surface. Some portion get infiltrated into the ground surface and it builds up the groundwater, and the rest of the water flows over the land. It fills all the depressions like ponds, lakes, and other small tanks and all. And the remaining water comes out of the catchment area. comes out of the catchment area, which is nothing but the outflow from the catchment area. So the input to the catchment area is nothing but the whatever the precipitation that takes place in a particular catchment area should be equal to the outflow. Outflow is nothing but the runoff of the overland flow plus or minus the change in storage. So the equation can be rewritten as I is equal to O plus or minus. Here we need to add minus, whether the change in storage may be plus or it may be negative also. That is plus or minus delta S. So delta S refers to the change in storage. So here the groundwater is taken as the integral part of the surface water. So no special consideration has been given for the groundwater. So the groundwater is considered as the integral part of the surface water. So hence the water balance equation or the water budget equation is nothing but whatever the input, that is the rainfall into the catchment area, should be equal to the output. Output is nothing but the overland flow or the runoff plus the change in storage, whatever the water that is held in lakes, ponds, or tanks and reservoirs. So that is nothing but the change in storage. So see now the change in storage includes the change in soil moisture storage, because soil will also hold some of the rainfall. Initially the soil will be dry. So whenever a rainfall takes place, the soil moisture starts building up. So it is known as the soil moisture storage. Next, there will be obviously a change in groundwater storage. And if there is snow cover, sometimes in places like northeastern part of India, we have the snow cover and the surface storage. Surface storage are nothing but whatever the water that is stored in the surface depressions, and also the channel storage. So all put together, so it is called as the change in storage. So that's why we use the sign plus or minus. Maybe in sometimes what happens, whenever a rainfall takes place, the soil will be very dry. It will absorb the moisture and it builds up the soil moisture. So immediately after one rain, again one more rain occurs. So already there will be soil moisture in the soil. So hence, the water will be not consumed for the soil moisture storage. So hence, the hydrologic water balance equation or water budget equation is I is equal to O plus or minus delta S. Now these things we have already discussed, different forms of precipitation and also the different types of precipitation, orographic precipitation, frontal precipitation, and cyclonic precipitation. Now, the next thing is we need to measure the amount of rainfall that has occurred at a particular place. So in order to estimate the amount of rainfall or the depth of rainfall in a particular area, we need some auxiliary instruments like rain gauges. So rain gauges are very useful to measure the depth of rainfall that has occurred in a particular area. So the instrument used to collect and measure the precipitation is called rain gauge. So it records the amount of precipitation, the intensity of precipitation, and the duration of precipitation, and the areal extent of precipitation. So by using the rain gauge, auxiliary rain gauges, we can know the amount of precipitation that has taken place and the intensity of precipitation in centimeters per hour or millimeters per hour, and the duration of the rainfall, whether it may be 2 hours, 3 hours, or 4 hours, and the areal extent, how much area it covers, the precipitation, that is known as the areal extent of precipitation. If the volume of water entering the rain gauge is known as divide, now divide it by the area of the catchment device to get the depth of the rainfall. So you know the water entering or the volume of water that is collected in the rain gauge, so which divided by the area of the particular catchment, particular area, that is the area surrounding that rain gauge. So we'll give you the depth of the rainfall, because the denominator is in meter cube and area is in meter square. So hence we can estimate the depth of rainfall in a particular area. So that is the depth per unit volume, that is meter cube by area. So we get the depth of rainfall in a particular area. So next is we need to locate the rain gauge according to the standards that is given by the Indian standards. That is how to locate a rain gauge in a particular catchment area or in a particular place. So the amount of rainfall collected by a rain gauge depends on its exposure, that is its exposure condition, and therefore great care must be taken for selecting a suitable site for a rain gauge. So the location of a rain gauge becomes a very important thing because we need to select an area that means surrounding that rain gauge. The surrounding that rain gauge, there should not be any disturbance or human interference. So such areas are where you don't have any human interference. So such areas are considered as the best for locating a place for to erect a rain gauge. Next, according to Indian standards, the following precautions must be taken while selecting a site for rain gauges. So Indian standards have given these following points. So we need to consider these following points before we select a suitable site to erect a rain gauge. So the site should be on a level ground. Preferably, the site should be on a level ground. Sloping ground, hilltops or hill slopes are not suitable. And second one is the site should be an open space. That means surrounding that rain gauge, it should be an open space. And horizontal distance between the rain gauge and the nearest object should be twice the height of the object. So any object that is surrounding that rain gauge, the horizontal distance between the rain gauge and that particular object should be twice the height of the object. Next is the site should be away from continuous wind force. So there should not be any wind force surrounding that rain gauge because the wind velocity or the wind force will distract the catch of the rain gauge, So you need to ensure that the area which you have selected is least affected by the wind forces. Next, the gauge should be truly vertical. It should be erected truly vertical, and the observer must visit the site regularly to ensure its proper readiness for measurement. So that means every day the instrument has to be calibrated. Whatever the calibration has to be done on each day, and the observer who collects the rainfall information, they should visit twice. One in the morning, that is at 8:30 a.m., and one in the evening, that is about around 5:30 p.m. So because here the data is collected manually, so a person who is in charge of that particular rain gauge, so he should visit the rain gauge station regularly, and he has to collect the rainfall data, one in the morning, that is at around 8:30, and one in the evening. Next, 10% of total number of rain gauge stations of any basin should be self-recording. So now, so far we have discussed a typical rain gauge, which is a not self-recording, it is non-recording type of rain gauge. So in India, throughout the world, we use a rain gauge called Siemens rain gauge, so which is a non-recording type of rain gauge. So we have to collect the rainfall data manually. So in some places where you don't have any access, then we need to erect a rain gauge which is self-recording. So here no human interference is there. Only we have a mechanism by which we can record the rainfall data. So it is automated. Hence, 10% of total number of rain gauge station of any basin should be self-recording. So because in a particular catchment area, you have some hilly tops or high hilly slopes. In such places, we cannot erect a non-recording type of rain gauges. So then we need to establish a self-recording type of rain gauge. So the self-recording type of rain gauges are the tipping bucket type rain gauge, so which is a self-recording rain gauge, and a flow type rain gauge. So where the rainfall data is recorded automatically. So it is not no manual intervention is there in case of the self-recording type of rain gauges. Now, so these are some of the points to be followed in order to select a particular place to erect a rain gauge. Now you can see the figure of a particular rain gauge. So here, the surrounding the rain gauge, a barbered wire fencing is done because to protect the rain gauge from the interference of the animals and other human interference. And the observer, he opens the gate, and every day, twice in a day, he collects the rainfall, whatever the amount volume of water that is collected in the instrument, and that divided by the area will give the depth of rainfall. Now here, how to place the rain gauges, placement of rain gauges. Now you can see the horizontal distance. The horizontal distance from any object should be twice the height of the rain gauge, and it should be erected vertically. And especially in hilly areas or sloping areas, we can have a self-recording type of rain gauge, self-recording type of rain gauge. So now, here the types of rain gauges. The types of rain gauges, the first one is the non-recording type of rain gauge, which is also called as the Simon's rain gauge, Simon's rain. Now, the recording type of rain gauges, we have the tipping or tilting bucket type of rain gauge, the weighing bucket type of rain gauge, and the flow type with siphon arrangement. So these three are the self-recording type of rain gauge, whereas the first one, the non-recording type of rain gauge, is the Simon's rain gauge. Now, this is the figure of non-recording type of Simon's rain gauge. Now, here you can see this is the rain gauge, correct? It is a metal casing. You have a metal casing. Inside the metal casing, you have a glass bottle. You have a glass bottle, and you have a funnel. You have a funnel that is, it is in the form of circular shape. That is, the rim is 30 centimeter above the ground level, and this is the funnel, and this is the glass bottle. So both these funnel and glass bottle are embedded in a metal casing, and the whole assembly is erected in a masonry block of 60 centimeter by 60 centimeter. And the top level of the rim of the rain gauge is about 25 centimeter above the ground level. That is about 30 centimeter above the ground level. So this is a very simple equipment. So here we have a glass bottle and we have a funnel as a receiver, and both these glass bottle and funnel is embedded in a metal, correct? Embedded in a metal casing. You can see here the metal casing, and the glass bottle is having a diameter of about 7.5 to 10 centimeter diameter. And here you have a circular rim. So this rim is 30 centimeter above the ground level. You can see here the top of the rim is about 37 centimeter above the ground level, and the whole assembly is firmly fixed on a masonry foundation block of 60 centimeter and 60 centimeter by 60 centimeter. Now, so the funnel receives the rainfall, whatever the rainfall. So here the top is open to the atmosphere. The top is not closed; it is open to the atmosphere. So whatever the amount of rainfall that takes place, funnel receives the rainfall and it fills up the bottle. So when the bottle is full, you can take out this bottle and you have a graduated measuring jar. So you can measure the amount of rainfall or the volume of rainfall that has taken place. So this volume divided by the surrounding the rain gauge area will give you the depth of rainfall that has taken place. So this is a very simple equipment. It is of non-recording type. So here the data has to be collected manually every day, once in the morning and once in the evening. Now here you have a recording type of rain gauge, so which is nothing but a flow type of rain gauge. So here you can see, so this is about 750 centimeter height, and here the top is 203 centimeter. So you have a circular ring. So the time is running out. So I request all of you to mark your attendance in the chat box. So please mark your attendance in the chat box. Now here in the recording type of rain gauge, so here this is the flow type of rain gauge. So here it is erected on the ground surface, and the top of the rain gauge is about 750 centimeter above the ground level. And here you have a funnel, correct? You have a funnel. And here you have a float chamber. So now you can see the float here. You can see the float. And here a graph sheet is wrapped around a drum, clock-driven drum. A graph sheet is wrapped around the clock-driven drum. So now, whenever the rainfall takes place, so the funnel receives the rainfall and it enters the float chamber. The rainwater enters the float chamber. Whenever this float chamber fills up, it makes the float to move up. It makes the float to move up. And here to this float, a pencil or a pen is attached to this float. And here you have a clock driven drum. So this requires rewinding once in a week. So this keeps on rotating. So whenever this float chamber fills up, the float moves up and the marker or the pen mark on the graph sheet. You will have a mark on the graph sheet. So whenever this float chamber is full, you have a siphon facility. The excess water siphons out from this siphon tube. So again, whenever another rainfall takes place, again the funnel receives the rainfall, it enters the float chamber and it makes the float to move up, and you will have the graph on the graph sheet. So this is a clock-driven drum. So it revolves, it takes 24 hours for one revolution. It takes about 24 hours to complete one revolution, and it requires once in a week. It requires rewinding. And a chart or a graph is wrapped around this drum. So whatever the marker, it marks like this, and you will get the graph. And from this graph, you can know the depth of rainfall that has taken place in a particular area. So this is a self-recording type of rain gauge, or it's also called as float type rain gauge. And the other two types of rain gauges is a tipping bucket rain gauge and main type rain gauge. So those are also the self-recording type of rain gauges, which are normally used in hilly areas or mountain areas where you don't have the access. Now, whatever the rainfall records are maintained by the following departments. Generally, the rainfall records in our country is maintained by the following departments. That is Indian Meteorological Department, and also the Agriculture Department, the Forest Department, and the Revenue Department, and the Public Works Department. So these departments have the rainfall record for a period of nearly 30 to 40 years. So because for hydrological analysis, we need a lengthy data. We need a lengthy data for a period of about 25 to 30 years, so that we can get the rainfall data in a particular place from these departments: Indian Meteorological Department, Agriculture Department, Forest Department, Revenue Department, and Public Works Department. Now, precipitation data error, the most significant cause of error in rain data. So every system has got some advantages and disadvantages. We cannot have 100% accuracy. So we have some errors. So these errors are due to the most significant cause of error in rain data. Observations are usually turbulent air flow around the gauge. So whenever you make observation, if there is a blowing wind, so it becomes difficult to get the data. Next, the dependence of rain gauge catch on wind speed, because if the wind speed is too high, the catch of the rain gauge gets affected. Evaporation from within the measuring cylinder. There might be chances of the water evaporating from the rain gauges to the atmosphere. Next is addition of water to funnel. Water then evaporates because water is received through funnel. So there in the funnel also there might be especially in the summer months, there might be some evaporation losses. And if there is any technical fault like gauge leaks, blockages, or overflow, so these are some of the technical problems. Next is error in observation and transcription. So that is error in observing the data and also recording the data. And splashing out. Sometimes some water will be splashed out of the rain gauge. So these are some of the possible errors in the precipitation data through rain gauges. So I request all of you to mark your attendance in the chat box. The time is running out. Do you have any questions? Hello? Do you have any questions? Purnima, are you there? ಯಾರಿದು ರೆಡ್ಮಿ ಅಂತ ಇದು ಮಾಡ್ತಿದ್ದೀರಿ ಪ್ಲೀಸ್ ರೈಟ್ ಯುವರ್ ನೇಮ್ ಅಂಡ್ USA ನಂಬರ್ ಹಲೋ ಯಾರಿದು ರೆಡ್ಮಿ Hello. Please write your name and USA number. Don't write Redmi and all. Your attendance will be not considered. Okay, I will be ending the session. So let's meet tomorrow morning. So till then, have a nice day. Goodbye. Thank you.